Okay, we are on day 1 of Unit 8. I know this is Chapter 9, but it is Unit 8. So this is 9.1 in your books. This is radicals and quadratic equations. Now, our objective is to be able to simplify radical expressions and solve quadratic equations. What do I mean by radical expressions? Hopefully you know, but in case you don't, a radical expression is one that contains this right here, the square root symbol. We are going to refer to it as a radical. Okay? Now, there is more than one approach when you have problems with radicals in it. First way, if you're good at mental math or you know a lot of perfect squares, is to find a perfect square that's a factor of the number. It doesn't necessarily have to mean, okay, well, it's the square root of 49, for example. We all know that's a perfect square because the square root of 49 is 7. That's not what I mean. For example, simplify the square root of 48. Well, what you want to do is look for a perfect square. What do I mean by perfect square? Like 4, 9, 16, 25, 36, 49, so on and so forth. Numbers that when you square root them comes out to a even number. Even not meaning like 2, 4, 6, 8, even meaning there's nothing left under the radical. So 48 factors of 48 are 16 and 3. 16 happens to be a perfect square. So we can put all of that under the radical. So we have the square root of 16 times 3 and then split it up. So we have the square root of 16 times the square root of 3. So basically, let me go back a little bit. We're starting with the square root of 48. We're saying, okay, 48, you can get that by doing 16 times 3. So if I can get that by doing this, I can say the square root of 48 is the same thing as the square root of 16 times 3. And then I separate it so that it's the square root of 16 times the square root of 3. And the square root of 16 comes out to a nice 4. Okay? We can't do anything with that square root of 3 though, so we're just going to say 4 times the square root of 3 and write it as such. Okay, so we're just going to keep it as a simple term there. Okay, so that's one way to do it. Now let's say you're not so good at mental math. Okay, you just want to keep dividing by the lowest numbers you can until you can't do it anymore, and then we're going to take the numbers out of the radical in pairs. Anything that's not in pairs stays under the radical. So for example, we've got the square root of 32. Well, it's an even number, so let's start with 2 times 16. Okay? Can't break down 2 anymore, but we can break down 16. 2 times 8. Can't break down 2 anymore, but we can break down 8 too. 2 times 4. And again, 2 times 2. Now we want to look and see how many pairs of 2's we have. Well, I've got 1 and I've got 2. So I've got 2 pairs of 2's, but that leaves me with 1 all by itself. So that 1 by itself is going to stay under the radical. And we only take, when we have pairs, we only take one of them out. The other one just kind of goes away. So we've got 2 2's. 2 times 2 is 4. So we could again say 4 times the square root of 2. Just write it like that. Get the idea? Okay, hopefully you have one way or another that works for you. Now, let's say you have to add radicals. Radicals function a lot like variables, meaning if you don't have the exact same term under the radical, you can't add them. Okay, just like you can't add an x and a y together, but you can add an x and an x together. Same concept. So we need to simplify each radical. So we've got the square root of 18, square root of 32, square root of 75. Okay, I like the perfect square method, so that's what I'm going to show you. If you prefer the other method, that's fine. You're still going to come up with the same answers. So square root of 18 simplifies to the square root of 9 times 2, because 9 is a perfect square. The square root of 32 simplifies to the square root of 16 times 2, because 16 is a perfect square. And the square root of 75 simplifies to the square root of 20, or square root of 25 times 3. Again, 25 is a perfect square. So then we're going to go ahead and separate those and simplify. Square root of 9 is 3. You can't do anything with the square root of 2, so it's just 3 times the square root of 2 plus 4 times the square root of 2, because again, this square root of 16, if you take that by itself, simplifies down to that. Same with the 9, in case you're wondering where I got these numbers. The 25. Okay? Now, if you notice, I've got 3 times the square root of 2 plus 4 times the square root of 2 plus 5 times the square root of 3. Remember what I said about the radicals. They have to be identical to do anything more with them. Well, we've got 2 here that have the same radicals. So we can add that 3 and the 4. Can't do anything with this, though, because it's got the square root of 3. And just like variables, they don't change when you're adding or subtracting. So that simplifies to, you take this 3 and this 4, and it adds up to 7, okay? Because they both have that square root of 2, which again you see right there. Can't do anything with this, so we just bring it down. Easy enough? I hope so. If you're a little confused, you will get plenty of practice in class. All right, now let's say you have a fraction under the radical. What do? It's actually pretty easy. We go ahead and say that the square root of 5 over 3 is the same as saying the square root of 5 over the square root of 3. Okay? Now, there's a rule with this. You cannot, absolutely cannot, have a radical in the denominator of a fraction. To get rid of it, you multiply the numerator and the denominator by whatever value is in the denominator. So in this case, we have the square root of 3 in the denominator. So we're going to multiply the top and the bottom by the square root of 3. And why do we do that? Because when you multiply a square root by itself, you lose the radical sign, okay? And then when you're multiplying radicals, you just do it the same, okay? Both of these are square roots, so I'm going to do the square root of 5 times 3, which is the square root of 15, because when you do this, this is the same, this whole thing here is the same as saying this, which is how I got this, okay? This, if you need a better visualization, is like saying the square root of 3 times 3, which would be the square root of 9, which would bring us back to 3. Okay, so you can write it one of two ways. You can say either the square root of 15 over 3, which is what I prefer, personally, not from a testing standpoint, or you could do 1/3 times the square root of 15. Entirely up to you, because the two answers are equivalent. All right, and solving quadratic equations. So let's say you have x squared plus 7x equals 0. Okay, this isn't a trinomial quadratic equation, so we can't do factoring here. But what we can do is find the greatest common factor. They both have an x in it, so let's factor that out. That'll give us x times x plus 7, because when you take the greatest common factor out, you're basically dividing both by that factor. So in this case, they both have an x, so we're dividing by an x. That goes away. X squared divided by x leaves you with 1x. You just have the 7 left. Okay, so you have x times x plus 7 equals 0. You're going to separate those two because one or the other could equal 0 for this to equal 0. Okay, this first x could be 0, and that'd give us 0 regardless, because 0 times 0 plus 7 is 7, but 0 times 7 equals 0. So you can just say that, or we've got x plus 7. Let's set that equal to 0. Okay, so there's one extra step you have to do there. You subtract the 7 from both sides. Those would cancel out, and that would give you this. So you could have x equals 0 or negative 7. Either way. Now let's say you have a trinomial quadratic equation. Well, this isn't exactly a trinomial the way it's written, because a trinomial, all the terms would be on one side, and it would be set equal to 0. So let's go ahead and do that. Okay, set it equal to 0. So we move that 16 over by adding it to both sides. And since it doesn't have a variable, we can't add it to either one of those, so we just tack it on. And here you would do your little x, however you like factoring. This is, if you can't do it in your head, this is where you can use the x and say, okay, well, I've got 16 on the bottom, negative 10 on top, which means that these two are negative. Okay, and I need two factors of 16, which in this case would be negative 8 and negative 2. Nothing in front of the x, so I just say x minus 8 and x minus 2 equals 0. Okay, once you've done that, you can just set those both equal to 0, and then we'll have to, of course, add 8 to both sides here, add 2 to both sides here, leaving us with x equals 8 or x equals 2. Okay, so hopefully you get the idea there. And again, let's move on. This one's a little bit harder. We have to solve 3 times the square root of 5 quantity squared plus 3 times the square root of 2 quantity squared equals x squared, and we're solving it for x. So we need x to be singular, not squared, but singular, to the first power. So first we figure out what this is. Now when you square a radical, remember the square root of 5 times the square root of 5 would just be 5. So anytime you have a radical squared, you're basically just getting rid of the radical sign. But you have 3 squared because this is in parentheses, so we have to distribute that to both. So 3 squared gives you 9, square root of 5 squared gives you 5. Same thing here. Okay, that gives you 9 and 2. 9 times 5 is 45. 9 times 2 is 18. That equals x squared. Add them together, 63 equals x squared. Alright, so this isn't a perfect square. And to get rid of a square on the x, we have to square root both sides. So that'll leave us with x plus or minus the square root of 63. Now think about how do you get 63? Now if it's not something that you can get anything out of, you would just leave it the way it is. But we can get 63 by doing 9 times 7. So we say plus or minus, because remember, when you square root like this, you've got to do plus or minus. You're not always going to use both, but in the case of this, where x isn't a measurement, it's not a measure of time or anything like that, you use both. So we've got the square root of 9 times 7, and we can take that square root of 9 and make it just 3. Square root of 7 doesn't go anywhere, so we would have this as our answer, plus or minus 3 times the square root of 7. That's what x equals.